Hi, welcome to AI 900, which is AI Fundamentals, part one of the prep class. I already have a previous video if you have a chance to check it out, which goes through kind of introduction to what this is going to be. And I talk a little bit around what the exam will look like and how you can expect to make your way through it with the most success. I should say this class is not at all an attempt to teach you everything you need to know around AI fundamentals. It is an attempt to help you successfully get through the exam, to pass the exam. So if you're going to use any of these concepts in real life, you are definitely going to want to do the learning path and follow the labs as well, and maybe have some nice discussions with your peers around the topics. And in fact, if you have a chance, have a chat with some industry professionals around the topics. However, what we're going to do here today is talk about the most effective way to pass this exam, and I will give you all of my top tips, and I will talk a little bit around the concepts as well, because it's impossible to pass the class if you do not pass the exam, if you do not understand the concepts. Okay, so my name is Michelle Sanford. I am a developer engagement lead at Microsoft. Connect to me on LinkedIn and say where you saw me and why you're joining with me. I also have a GitHub repository. Excuse me. As soon as I'm talking, I want to cough. GitHub repository where I often put my notes. So when I'm studying for an exam, I'll make a lot of notes around that exam. You can check out those notes on my GitHub profile. If you like it, give it a little star. Yeah, I've passed everything that I have sat so far. Not always on the first attempt, but yes. I guess I should say the one that I did not pass on the first attempt was the IoT Developer Specialist exam. That was a little bit hard. That was quite hard, but I passed it on the second attempt. So I guess the lesson is keep going. Try again. So these are some of the ones that I have passed so far. They are not everything, and they will not be everything because I try to do another one each month if I can. So today we're going to do part one. We're going to talk about AI workloads and considerations. Now, this is my first top tip. When I am studying for an exam, I will draw a little mind map out. It's quite hard to get that on one A4 slide. So what you have here is more text than drawings. But what I've put there is I've tried to split the workloads out into all the ones that there are there. In fact, the one in this top left-hand corner to me, prediction forecasting, that one is not a workload as such. I should have put machine learning in there, but yeah, I guess the prediction forecasting part is the part that I find most interesting and comes up really a lot in this exam. So that is why that one's slightly out of step with the rest of them. When you're making your notes, you should do what makes sense to you. But I've tried to group the things that I saw coming up again and again in the learning path in practice question sets. And indeed, they did pretty much match to the exam. So yeah, this is what I've done is I have put the workloads out and I have put some examples of what each of those things will look like. And you'll see why I've done it like that as we look at some of the practice questions in a bit. Okay, so artificial intelligence workloads are 15 to 20% of the exam, and it's kind of split into two parts. The what are artificial intelligence on Azure and responsible AI. The artificial intelligence in Azure, I would say, is the technical part, The responsible AI is the planning part and the strategic part. So, in fact, both parts are really interesting and really important for when you're talking to future employers. But the responsible AI part is particularly interesting if you're having strategic and high level conversations with people from within the business or higher up managers and leaders. So, like, you might talk more to artificial intelligence in Azure in your first interviews, but then go deeper into responsible AI when you're having your second and third interviews with higher level managers, maybe. Uh, in fact, if you don't plan for responsible AI before you code or before you stand up your tech, then you're going to be in trouble anyway. So you do need that at a technical level as well. So yeah, I don't know, it's all cool. I think this is a really cool exam with really a lot of interesting content in. And so I think it's easy to pass because it's easy to be interested in this stuff. Okay, here we go. So what is artificial intelligence? The definition is it's software that imitates human capabilities. So in machine learning, a computer model makes predictions and draws conclusions from data. And anomaly detection, it is the capability to automatically detect errors and unusual activity in a system. Computer vision is the capability of software to interpret the world visually through cameras, video, and images. And natural language processing is the capability for a computer to interpret written or spoken language and respond in kind. And then conversational AI is the capability of a software agent to participate in a conversation. So what I've done on this screen is I've tried to put each of those topics out and then give some examples of what that looks like in real life. So if you were going to build that thing in industry, what would it look like? The reason I've done it like this is because that tends to be the way they structure the questions in the exam. They will say, will an airplane arrive early, on time, or late? Is an example of machine learning or computer vision or conversational AI, for example. Or they might say, detecting pedestrians in real-time video stream of an autonomous vehicle is an example of natural language or computer vision or machine learning. So being able to identify what you can do with each of these AI workloads is going to help you to answer those questions in the exam. And there's not like a huge number of examples that they use. They use the same examples all the time. And you can see how each of those workloads would apply to different industries. But generally, once you can see clearly in your mind the kind of thing that you're going to do with it, it's easy for you to think, well, I know what that is. That's that. So try and, spend a little time understanding what each of the things is and in what situation you would use those things. And then in Microsoft Azure, artificial intelligence is split into these three things. So I should warm up my voice a bit more before talking to you all. So you've got Azure Machine Learning, which is a platform for training, deploying and managing machine learning models. You've got Azure Cognitive Services, which is a suite of cognitive services developers can use to build solutions, and Azure Bot Services, a cloud-based platform for developing and managing bots. There is a lot of automation, a lot of stuff done for you in each of these things. So it's possible to do a lot of the work that you need to do as a machine learning or an AI engineer without actually coding. There are often choices, and you can do it in the code, or you can do it more in a sort of drag and drop design studio type scenario. So you don't need to necessarily in real life know how to do all of the things in all of the ways. I avoid coding whenever possible. I actually really like coding, but I don't want to do unnecessary coding. My coding is not as clean and as neat and as short as it could be. And so if there is a way that the tool will do what I need it to do by me, dragging and dropping it or some other format, I will choose that above the code. And then I will use the code for making stuff that has not been done by someone more expert than me. So I guess, use the templates, use the automation if you can. You need to, for the exam, you need to recognize the different ways there are that you can do things, and you need to sort of know what they look like. And it will sometimes ask you to order those things, like what order do you do things in? What do you choose? More likely in the AI 100, so the associate or the AI engineer exam, than in the AI fundamentals exam. I actually do really recommend you study for both exams together. I did them one day after each other, and I found that really helpful because the knowledge in one builds into the other. But if you're just doing AI fundamentals, then don't really allow yourself to get stuck on how does it actually work? What does it actually look like? It will be enough if you understand the concepts, if you've been through the learning path a couple of times, and you're sort of familiar with what does what and why. Okay, so if you've done the learning path, then you'll recognize this GIF. And I do recommend that you do the learning path more than once. I would say go through the learning path once quite quickly, not really worrying if there are some concepts that don't make sense on the first read. When you go through them on the second time round, they will make a lot more sense. I actually have to go through things several times because my brain is impatient and I kind of want to get to the end of the learning path and know what happens as if it's a book, which is crazy. But indeed, there are some things that don't make sense to me before I understand how everything fits together in a big picture. And so it makes a lot of sense to me to go through everything first, try and understand that, and then go back and understand the individual pieces in more depth. You don't have to study the same way that I do, but I guess my tip is don't allow yourself to get stuck. Don't be paralyzed by fear that this is too hard and you don't understand it, or it's too deep, or if you don't get that concept, you won't get the rest of the concepts. Don't do that. Move on and come back to it later. It'll be fine. And indeed, if there was one particular concept that you didn't get at all, even after multiple goes, not to worry either. You should still be able to pass your fundamentals exam, even if you were missing one concept, because there are, about 40 questions, maybe more. And losing one question is not going to stop you passing the exam. Okay, so what we're looking at here for machine learning is that a team of botanists and scientists collect data on wildflower samples. The team labels the samples with the correct species. The labeled data is processed using an algorithm that finds relationships between the features and the samples on the labeled species. And then the results of the algorithm are encapsulated in a model. And when the new samples are found by volunteers, the model can already identify the correct species label. This is all in the learning path. I just wanted to give you a little example. Here's a little example of the understanding anomaly detection. I cannot say that, no matter how many times I try. Sensors in the car collect telemetry, such as engine revolutions, brake temperature, and so on. An anomaly detection model is changed to understand expected fluctuations in the telemetry measurements over time. And if a measurement occurs outside of the normal expected range, the model reports an anomaly that can be used to alert the race engineer to call the driver in for a pit stop and fix the issue before it forces retirement from the race, or worse, before the car explodes. Yeah, so that is pretty cool. Also in the learning path. Here we go. So this is computer vision models and capabilities. So here are 6 different examples of things. What we're looking at is image classification, which involves training a machine learning model to identify images based on their contents. For example, in a traffic monitoring solution, you might use an image classification model to classify images based on the type of vehicle they contain, such as taxis that we see there, buses, cyclists, and so on. And then you have object detection machine learning models, and they're trained to classify individual objects within an image and identify their location with a bounding box. So that's the one that you see underneath the taxi. And it says like bus, car, cyclist, that kind of thing. And it's like a square box around it. And then the next one, so the one next to the taxi, is semantic segmentation. This is an advanced machine learning technique in which individual pixels in the image are classified according to the object to which they belong. For example, traffic monitoring solution might overlay traffic images with mask layers to highlight different vehicles using specific colors. Semantic segmentation is what you'd want to be using with your self-driving cars. You don't want it to just have like a generic box around stuff. You want it to really precisely to the pixel know where everything is and be able to identify, well, pedestrians, children, animals, I don't know, everything in there. So you can create solutions that combine machine learning models with advanced image analytic techniques to extract information from images, including tags that could help catalog the image, or even descriptive captions that summarize the scene shown in the image. So you see like that one underneath the semantic segmentation one, we see a person with a dog in a street. That technology is used in the Seeing AI app, for example. So blind people can use their phone to report to them what is happening in the world around them and say, you know, there is this there, and, you know, ahead of you is a wall, stuff like that. Face detection, so top and one in the top row, that one is a specialized form of object detection that locates human faces in an image, and this can be combined with classification and facial geometry analysis techniques to infer details such as age and emotional state, and even recognize individuals based on their facial features. I always say this one is the one that has the greatest capacity to do good or be used for evil. So, you know, you can absolutely, it has been used to find victims of human trafficking, to find lost children, to find terrorists in crowds, but it has also been used incorrectly and badly to arrest people who were, well, in a badly trained model. It might identify, for example, a black man as the person who had committed the crime, just because any black man it would have identified as such. And in the beginning, the training models were definitely not trained well enough on people of color. And so therefore they were picking out wrong people. And then where the police are either overworked or lazy and not doing their jobs properly, they don't investigate the alibis. They just went on what the tech said, and the tech is wrong. The tech was wrong because the models were badly trained with not enough information. So yeah, it can be used really well and to do great good and to save an enormous amount of human time and energy. But you have to use it responsibly. You have to get good data and lots of it, and you have to do your due diligence around it as well. Investigate people's alibis. Don't just be saying, well, the tech said. That's not enough. But we'll go more into responsible AI as we move on. This is just a summary. The bottom one there you can see is OCR, or optical character recognition. So this is a technique where you have writing in the photo and the tool can scan it and it can take that text out of photographs or screenshots, and then it can translate it into text into your notepad. So for example, when you would take a picture of your lecturer's notes on the screen or their PowerPoint presentation, you could paste that into your OneNote. You could right click on it, extract text from image and paste it, and then you would have the text in there without having to write it out by hand. That is really cool, I think. I use that all the time when I'm studying. Okay, so conversational AI in Microsoft Azure. The thing that came, well, not first, because we have been 20 years, more than 20 years building conversational AI. When I did my dissertation, I did it on one of the original chatbots, chatbot called Eliza, who was one of the initial attempts to pass the Turing test. And I guess she pretty much passed it. But she did it by imitating the way human counselors work. So, for example, there's a particular reflective technique where you would say, I feel really sad today. And then the counselor would say, oh, I see you feel really sad today. Why don't you tell me more about that? And then you'd say, oh, well, my mother's been getting on at me to study more and I feel really stressed. And then the counsellor would say, oh, yeah, I see your mother's stressing you out. How do you feel about that? And it's that technique was employed in the first chatbots, whereas now there are so many more sophisticated techniques that are incorporated and are already done for you before you even start building your own chatbot. So Q&A Maker is a really quick way that you can build a knowledge base of questions and answers, and this can form the basis of a dialogue between a human and an AI agent. So people are using those on, when you go to websites, a little thing will pop up saying, do you need some help with that? And they can answer your basic questions, or they can pass you to a human agent if the scenario gets too complex. But you can also put some personality into those things so that it is not as boring and as clumsy and cumbersome as they used to be. You can also completely customize those things. So Azure Bot Service, it's a platform for creating, publishing, and managing bots. And developers can use the bot framework to create a bot and manage it with Azure Bot Service. And you can quite easily integrate backend services like Q&A Maker and Lewis, which is language understanding. And you can connect to channels for web chat, email, Microsoft Teams, Power Platform, Facebook, all of that. You can connect those bots to it. There are a lot of templates in there, and you can write your own code from that base template, but it really gives you a great start. So we're going to do some practice questions for now. So remember I said at the beginning, they'll ask you for examples of what things look like. So which scenario is an example of a forecasting AI workload? Detecting the language in the provided text document. So that is language translation. Detecting pedestrians in real-time video stream of an autonomous vehicle. So that's going to be a vision workload. Predicting whether an airplane arrives early, on time, or late. That's going to be the one. Providing answers to a customer in a chatbot dialogue. That's going to be bot related. So predicting whether an airplane arrives early, on time, or late is an example of the forecasting AI workload. In the forecasting AI workload, a machine learning model analyzes patterns in the provided data, such as your time of departure, weather conditions, air traffic control, etc., and it associates those historical patterns to predict or forecast the possible outcome. So whenever you see the word forecasting and prediction, like that is quite often going to be a sort of pattern matching word. What do you call that word? Well, look for those words, and often that will be the answer. Forecasting, prediction, historical is generally those three things you'll see together. Detecting the language is a natural language processing AI workload. Providing answers to a customer in a chatbot dialogue is a conversational AI workload. And detecting pedestrians in real-time video stream is a computer vision AI workload. So when you're like, if you find any sample questions that you're looking at, I would not trust the internet, by the way. If you're going to the internet and looking for questions and answers from exams, do not trust them because they are not always correct. And in the AI ones, definitely I have seen incorrect ones there. But what you want to use them for is just to sort of trigger your mind and say, what am I looking at here? What am I matching here? And you're not just looking for what is the correct answer, but what are all the other ones? What are the actual answers for all the other ones? So it's important to recognize not just that forecasting and predicting go together, but that there is custom vision there, and that there is chatbots, conversational AI, stuff like that. Cool. So which scenario is an example of a natural language workload? So detecting whether people in online posted images are celebrities. So that's going to be some sort of object detection thing, or custom vision, something like that. Predicting whether a customer would buy certain items based on their purchase history. So there again, you'd be looking for the words forecasting, regression, historical, predicting. All of those things go together. Using graphics and menus to improve the user experience with an e-commerce website's chatbot. That's a bit of a trick to you there, because you're seeing the words chatbot in there and you're thinking, well, chatbots are natural language workloads. However, it's not talking about that. C is about using graphics and menus to improve the user experience. So it's trying to trick you with the word association there. And the final one, analyzing customer feedback on an e-commerce website to determine whether it's positive or negative. So this is sentiment analysis, which is an example of a natural language workload. So that's that one. That's the correct one, D there. The predicting one, as I said, is a forecasting AI workload. The using graphics and menus to improve user experience is an example. It is an example of a conversational AI workload, but it's talking more about the interactive components such as graphics, menus, and buttons to improve the user experience. It's not talking about the other part. And then detecting whether people in online posted images are celebrities. That's a computer vision AI workload. So the model is trained using domain-specific content, in this case, celebrities. So there'll be like a whole catalogue of celebrities in the model already, and it can determine whether it sees like Brad Pitt or Angelina Jolie in there. Maybe not all of the new ones, but the big ones be in there. Something is the process of using machine learning to monitor and detect unexpected items or events in time series data that differ from the norm. So remember, that was the racing car one, so that I can't pronounce. So that's definitely anomaly detection. Prediction would be forecasting who's going to win that race, maybe. And knowledge mining might be going through all of the historical data around. I shouldn't use the word historical, that might put you off. But knowledge mining can use the power of AI to help you deeply understand and explore vast amounts of information to get better insight and uncover hidden relationships and patterns in the data. So you might be, investigating the history of a particular race team to find out how much money has been spent on those teams over time. What happens when they have a weaker engine? Do they get stronger drivers? Whatever stuff. But knowledge mining research. So this one was anomaly detection. For which of these scenarios should you use an AI-based prediction solution? Detecting abnormal events in a vehicle's engine, detecting the speed limit using roadside signage, determining the distance to the vehicle in front, and determining the likely repair costs of an accident involving a vehicle. So the first one is anomaly detection. That abnormal is generally, in fact, even detecting an abnormal is quite commonly used with that anomaly detection thing. Detecting speed limit using roadside signage. I think we're probably doing OCR there. Definitely computer vision, because it's reading the sign. And determining the distance to the vehicle in front would be another computer vision workload. So it can detect objects from 2D images and video streams, and the distance to these objects can then be calculated. Determining the likely repair costs for an accident involving a vehicle is going to be the one for which we would use a prediction scenario. And the reason I say that is because in a prediction AI workload, the machine learning model finds patterns in the provided information, such as the amount of damage, the location of the damage, the parts damaged, and this is compared to historical data on previous car accidents or car repairs, and then it can predict the amount of time required to repair the damage and consequently the cost of the repair. I hope I'm not going too quick. For which scenario should you use computer vision? Translating commands into actions. Hey Siri, turn off the lights. She's not going to respond here because Siri does not live in my house. Detecting anomalies in health scans. So this is looking at a whole bunch of x-rays of people and seeing which ones are normal and which ones have cancer or tuberculosis or something else in them. Finding, so that's obviously going to be like a custom vision thing. Translating commands into actions, the first one, that's going to be voice. What is that? What do you call that? Brain is not engaged yet. Natural language processing, of course. It's understand what I say, process that, and then translate that into a different command, into an action. Oh, what a fool I am. Detecting anomalies in health scans is going to be computer vision. Finding relevant information to answer a specific customer question. So this is going to be a combination of conversational AI and natural language processing. So like generally you're going to have, the bots, the chat bots in a website or something like that. Customer's going to ask, what's the cheapest flight from Perth to New York? And then it will look that up and see if it can find it. And if it can't, then it will have to pass that on to a actual travel agent who will then look at the complicated multiple changes and times and stuff like that in order to provide the answer. Discovering financial system fraud. This might be looking for patterns in the data that would indicate fraud. So yeah, I guess you would use anomaly detection to discover financial system fraud. So which ones would use computer vision? So not the first one, natural language processing. The second one, definitely. The third one, no, natural language processing as well. And the fourth one is going to be anomaly detection. So yes, the one that we want is the detecting anomalies in health scans. Oh, so I guess what I'm trying to say there is it is possible to logic your way to the correct answer, even if you aren't certain exactly which one is the correct answer and you aren't certain of exactly which technology you're using for each. You can still sort of, rule your way through them, crossing some out, saying it's definitely not that because that's that. It's definitely not that because that's that. I think it's going to be this one. And then just like checking, that you've ruled out all the other ones before you say it's that one, even if you aren't sure of the exact term or tool or technology or workload that it is. And yes, that is a great way for you to work your way through this exam. I say it in the introduction and I'll say it again here though. There's at least 40 questions in this exam. You don't have a lot of time, so you don't have 10 minutes to spend on the first question where you're puzzling it all out. Go through as quick as you can and answer all 40 questions. If you don't know it straight away, tick something and then tick the little box that says review this later, and then you can come back to it at the end. Work your way through, make sure you've answered every question as quick as you can, and then go through and do it more slowly on the second run. The reason I say this is when you first start the exam, your brain is going to be kind of frozen in that fight or flight mode. It's going to be panicking. Every question it sees, it's going to be thinking, oh my God, I don't know this. I don't know anything. I'm an idiot. Don't listen to that voice in your head. That voice is not your friend. Do a few questions, get into the rhythm of it, get a feeling for them. And then when you come back to that first question at the end, you'll know the answer immediately. And you're like, oh my goodness, that's such an easy question. And I didn't see it because my brain was in panic mode. So yes, go through, do what you can, answer the easy ones quick, and then come back, review them slowly. And the ones that you don't know, you'll have time to do some sort of logicking them out. That's the definite trick for these. The people I know that fail, most of them, is because they did not answer every question rather than they got too many questions wrong. Okay, which of these two scenarios should you use conversational AI? Making a travel reservation, so we're going to use a bot for that. That could be conversational AI. Detecting spam in emails. It is doing some language processing there. Detecting a change in hospital infection rates. Well, this is going to be like a anomaly detection maybe, or like a historical regression type thing. Translating speech from one language to another, it's language translation. And answering frequently asked questions, that is a chatbot thing as well. So travel reservation and frequently asked questions would definitely be my picks there. So let's see. AI agents engage in conversations with human users. Bots use natural language processing to make sense of human input and identify the actions a human wants to perform. It also identifies the object that the action is being performed on. So bots can also prompt the human for information required to complete a transaction. A common use for bots is to make travel reservations. Another use for conversational AI is responding to human questions with answers from a knowledge base of questions. So conversational AI with NLP can find the most appropriate answers from the question and answer pairs. This provides the answer back to the human. So change in hospital infection rates is an anomaly detection. It detects unusual patterns in time series data. Conversational AI cannot detect spam in emails. It's a feature of NLP, natural language processing, that can analyze the text in the email and determine if the email contains a spam message. And it can't translate speech from one language to another. This is also a feature of NLP, in particular, the speech services. So you'll see, like, you have the top level workloads, and they all have these different component services within them. Some of the questions are asking you, is this custom vision or is this conversational AI? But some of them are going deep into the detail of within conversational AI, what component is it? So that initially was one of the things I got confused with, because I was thinking, detecting spam in emails, that is definitely something to do with natural language processing. And so is conversational AI. And so, in my head, I'm like, well, all of these things are the same thing. They are, but they're different levels. Some of them go deeper. So some of the services are smaller things within the bigger thing. So you need to be able to group them into those overall workloads, but then also know the detail of what different things they do. It sounds like there's a lot there, but actually it makes a lot of sense, especially when you study it in this format, sort of looking for examples and what those things look like so you can make them real in your mind rather than just academic. Okay, responsible AI. This is really cool. There are a bunch of challenges or risks in using AI, and we have to be super cautious that we are using AI responsibly and that we are aware of the biases and the errors and the data and the complexity that can make things, well, these things can all impact people's lives if the AI decides incorrectly and we just run with it. So it's really important that you consider each of these things. There's a really nice section within the learning path on it. And also you can, if you just search for Microsoft's responsible AI, there is like a huge component, a huge part of the website that you can look at. And there are videos, there are examples, there are stories, and it really makes you think, oh my goodness, we have to consider all of these things before we build, before we design, and definitely before we deploy this stuff. So these are the principles of responsible AI. Now, the trick with the questions surrounding these is that all of these things are good things. They're all about fairness, about privacy, about security, transparency, accountability. And the questions they will give you concerning them will mix and match. So they will ask you something and say, is this part of the fairness principle? And you'll think, because they're saying like it's a really good thing that needs to be done, that the answer is yes. But no, the answer is it's not part of the fairness principle, it's part of the privacy and security principle, or it's part of the transparency principle. And so you have to very clearly understand in your mind what each of the components of responsible AI are and what they mean and what they look like in real life. So, for example, fairness, or AI systems should treat all people fairly. So, a fairly common example is the loan app approval, and it should make predictions on whether or not the loan should be approved without incorporating any bias on gender, ethnicity, or other factors that might result in an unfair advantage or disadvantage to a specific group of applicants. So, for example, you can't say we're going to charge women more for car insurance because they're worse drivers than men. First of all, because that's not true. Statistically, you can prove that men are worse drivers in terms of number of accidents, damage, stuff like that. But secondly, because yes, you can't just judge on whether a person is a worse driver because of their gender. You should be judging them on only them. Do they themselves have a history of accidents? Have they made a lot of claims in the past? That kind of thing. They, not their entire gender, not their entire race, not everyone within that age group. Although, actually, I do think that I think they do tend to charge you more based on your age group, but that is because they have a statistical thing showing that the younger you are, the more likely you are to have an accident. Anyway, that's what that principle is. Reliability and safety. So AI systems should perform reliably and safely. Unreliability in these kind of systems can result in substantial risk to human life. Rigorous testing and deployment management processes to ensure that they work as expected before release. So if you see stuff around testing, is definitely going to be in that reliability and safety one. Privacy and security, where they're talking about the personal information being kept private. Inclusiveness. AI systems should empower everyone and engage people. AI should bring benefits to all parts of society, regardless of physical ability, gender, sexual orientation, ethnicity, and other factors. I find so that there's a question around this that I saw both in the practice exams and in the real exam, and it just makes me mad because it says that the principle of inclusiveness and means that everyone has equal benefits, and we'll change the world or something like this, and it doesn't. What it means is that is the goal, but it doesn't mean that has been implemented, because it is impossible at this stage to implement a fully inclusive system that has changed the world for the better. So don't let the wording there fool you. Where it says will or is or something like that, it means should. It should empower everyone and engage people. Transparency, so you can see through everything and clearly understand and be aware of the purpose of the system and how it works and what the limitations are. And accountability is someone who's going to be held responsible for this. And what is that? Who is that? How do you, if you are injured in some way by this system, who are you going to be able to hold accountable? Who are you going to be able to blame? Who are you going to be able to get your money from? So I made like a little picture as well of that, sort of showing some of the examples as to what those things look like. I recommend you make your own notes so that you clarify it in your head and maybe draw more pictures than I've got in there. I think I've kind of gone through each of these. They are all in the learning path and also on this Microsoft AI website. Okay, let's practice some questions. A company gives clear explanations on how banking AI systems work and what factors it considers in approving loan applications. Which responsible AI principle is this an example of? So, clear explanations. The word match I would see there is clear and transparent. Clear explanations, transparency. You want to say that it's about accountability because, you'd be able to go to the bank manager and say, I demand you make this right. You want to say it's about fairness because, if there's a clear explanation, then hopefully it should be fair. However, you have to go to the first level of the question. It's asking what principle gives clear explanations, and that is transparency. The transparency is a guiding principle of responsible AI that requires the system to be understandable. System users should understand how it operates, what data it uses, and the system's capabilities and limitations. Okay, company carries out rigorous testing and deployment. Testing and deployment are the keywords there, and we match those to reliability and safety. As I said before, you will often see it talking about driverless cars, taxis, trucks, whatever, because yes, reliability and safety is the thing in most people's minds when they are thinking about that. And of course, yeah, it goes a lot deeper if we're looking for who to blame, which is difficult to put into a question. So yes, that's reliability and safety in there. For each of the following statements, select yes if the statement is true, otherwise select no. According to the transparency principle, all systems should treat people fairly. No. According to the fairness principle, AI systems should treat all people fairly. According to the reliability and safety principle, AI systems should be secure and respect privacy. No. According to the security and privacy principle, AI systems should be secure and respect privacy. You see the trick of it now. According to the accountability principle, people should be accountable for AI systems. Yes, people are accountable for AI systems. Somebody wrote that code, somebody programmed that car, somebody drove that car, somebody jumped out in front of that car. People are responsible, according to the accountability one. Match the responsible AI principles to the objective. A principle may be used once, more than once, or not at all. Protect personal information is privacy and security, PII. Quantify risks and harm to life. I think it's going to be reliability and safety. And gain trust from users. Ooh, see, that's a tough one because all of those things will gain trust from users. The question is which one it has it directly as part of its primary, a core part of its principle. So it's either transparency, they can like clearly see and understand how the system is working. Fairness, they know that everyone is treated fairly. And accountability, there's someone that can be held accountable. I think I'm going to go with transparency because that's like at the very top level. Yes, transparency enables users to be able to trust an AI-based solution by informing them of the scope and purpose of the solution, as well as informing them how the data is used and the limitations of AI processing. If we look at the other ones, yeah, I mean, all of them are definitely going to help build trust, but the transparency one is the primary one, the first one that is going to ensure that trust is there. So you have to kind of logic your way. Like if you don't know them, if you don't have an eidetic memory and have memorized all the principles word for word, then you can absolutely logic your way to the solution based on ruling things out. Awesome. Okay, so we have reached the end of part 1. And I hope you've liked this video, and I will see you in the next video that I'm going to make for part 2.